So hello students, today we have talked about the motion of connected bodies. So this is the first case when the motion of two bodies connected by a string over a smooth pulley. So this is a well known problem, that is a etude machine. So this is the M1 and this is the M2. Okay, here we can consider that M1 is greater than M2. Okay, here M1 is greater than M2. So in this case, first we can draw the free body diagram for the each and every mass object. Okay, so here if M1 is larger, so the A is acceleration acted downwards for the M1 as well as M2 is at upward. So for this M1 body, your M1G minus T equal to M1A, and for M2 body, see the net tension on this mass is T minus M2G, because in this case since the M1G is goes downward, so the M1G is larger, so M1G minus T equal to M1A, while in this case M2 is goes upward, means this tension is larger compared to this weight, so T minus M2G equal to M2A. So by solving these two equations we can obtain the final expression for the acceleration as well as final expression for the tension. Okay, so by solving this equation we can obtain for the equation for tension is 2 M1 M2 upon M1 plus M2 G. So here if we suppose, because both pulley have the mass object is attached with the same pulley, same string, so the tension is same, and in this case this tension and this tension, the angle between these two tension is 0 degree, while P is T, Q is T. So by solving this equation we can obtain for the resultant expression, that is 2T. So the resultant of these two tension is 4M1 M2 upon M1 plus M2 times G. Okay, now the problem based on this question is that a system of frictionless pulley carries two weight hung by inextensible cords as shown in figure this. Make calculation for the tension in the cords and acceleration of the weights. Okay, also proceed to work out the displacement and velocity of weight W1 after 4 seconds from start. Okay, presume that the system is released from rest. Okay, so how can we proceed to solve this equation? First we can understand. Okay, so here we can consider two blocks A and B. So A having 200 Newton weight and B having 50 Newton. So focus on this object. Okay, so this, since A is going upward, means this mass is less compared to this acceleration. So the tension is larger in this string. So T minus 50 equal to 50 upon 9.8, because this is M1A. Okay, so how can we determine the mass? That is this load divided by gravitational acceleration. So T is equal to 50 plus 50 upon 9.81 A. Okay, and if it is accelerated by A, so it is accelerated by A by 2. Okay, because this A by 2 is divided in this part as well as this part. Okay, so in this case if A is going downward, so means your 200 minus 2T, because this T and this T is acted in same direction. Okay, so this is here, if it is 2T, so it is divided into T and T. So 2T minus 200 equal to 200 by 9.81 into A by 2. So by solving this equation again we obtain for the expression T equal to 100 minus 50.9.81 A. So by solving 1 and 2 we can obtain for the expression for T, that is 75 Newton, as well as acceleration. Okay, acceleration is 4.905 meter per second square. Okay, now proceed to work out to find the velocity as well as the displacement of the body. So U is equal to 0, because the motion is started from the rest. Okay, and the also we have worked out the displacement. So by using this A is 4.905 and 4 seconds, so it is 19.62 meter per second, as well as we can determine the displacement by again u is equal to 0 and t is equal to 4, a is equal to 4.905, so it is comes to be 39.24 meter. Okay, now the second part is the motion of connected bodies when the edges of a horizontal surface. Okay, now how can we proceed to determine this? Okay, so in this case again there are two objects, this and this. So for this object again, if A is acted downward, means m1g is larger, so m1g minus t equal to m1a. Okay, and for this again, because here the tension is acted in this direction as well as in this tension is same. Okay, so t, and if it is this motion m2 is going in this direction, so the frictional force is acted in opposite, so the net force or net resultant of force on this body is nothing but T minus mu r. Okay, T minus mu r equal to m2a. Okay, and r is nothing but m2g. Okay, so now by this free body diagram we can obtain for the final expression, which is this. Okay, so m1g minus t is equal to m1a, that is for this object, because this m1 is going downward and a is acted upward, so m1g and here t tension, so m1g minus t equal to m1a, and similarly for m2 is t minus mu m2 is equal to m2a. Okay, again by using these two equation we can obtain for the acceleration as well as tension. Okay, now our next part is to determine the resultant acceleration. Okay, here we can obtain for the final expression for the for a smooth horizontal surface by putting mu equal to 0. Okay, so the in order to determine the pressure or reaction on the pulley here, so this is pulley and this is yoke. So one tension is in this direction and one tension is in this direction. So theta is equal to 90 degree and both the direction again tt. So if put theta is equal to 90, so it is comes to be root 2 times t. Okay, now the third part, motion of two bodies connected by a string, one hangs and free and other and rough and connected. So again by this is the same, and in this case if his motion is in this direction, so the mu r2 is in this direction, so the net force on this object is because motion is in upward direction, so t is larger, so for this body t minus mu r2, t minus mu r2 equal to m2a. Okay, so by using again these two expression we can determine the a as well as t. So the first expression is m1g minus t equal to m1a, and the second expression is nothing but m2g sin alpha, because in case of this expression your m2g is this direction and your r is in this direction, either m2g cos and here sin alpha. Okay, this is t and again this is mu r2. So by solving this expression for the net acceleration we can obtain the t minus m2g sin alpha minus mu m2g cos alpha to m2a, and by using these two equation after solving we can obtain for the final expression is that t is equal to nothing but this. Okay, and a is equal to this, and in this case your alpha, if one angle is alpha, so another angle is 90 minus alpha. So by solving this equation we can obtain for the resultant, that is t under root 2 1 plus sin alpha. Okay, so thank you. This is simply mathematics, so you can solve by yourself. Thank you.